Hi and welcome. My name is Rafael Taubinger, and this short video is about the new version 3.11 of IAR Embedded Workbench for RISC-V. We are broadening our support for instruction set extensions and adding support for new cores from various RISC-V partners globally. It is clear how the RISC-V ecosystem is growing when you take a look on the device core IP list displayed on the screen from various partners like Sci-Fi, Canon, Andes, Microchip, Codasip, Western Digital, Nuclei, Open Hardware Group, and more that we added support. And also the integrated solutions like Microsoft Azure RTOS ThreadX. And we are adding full support for the Andes CoDense extension, enabling code size compression on top of the RISC-V-C extension. Our benchmark showed a double-digit code size reduction. We also added the P extension, focusing on accelerating the performance of applications. The C-SPI debugger got enhancements related to symmetric multicore processing and asymmetric multicore processing in multicore debugging, including support for the different RISC-V and ARM cores on the same JTAG chain. Notice that IJAC is required for this. Great! Let me show the IDE and Andes CoDense extension in practice. So I have here IAR Embedded Workbench for RISC-V version 3.11 open. And once you start the IDE, first is actually the information center that will be displayed for you. So we have under example projects various projects available. So it's kind of a generous list that you can make use. Additionally, if you are looking for some extensions and integrations, we can provide you here some examples when it comes to RTOS, like FreeRTOS, SafeRTOS, and Microsoft Azure RTOS that's available for you. What I'm going to use here is already out-of-the-box Andes project, and it's doing some decompression on JPEG. And as I mentioned before, if we look here inside the settings, you will see that the list of devices we support is kind of generous. It's a huge list of devices, partners that we are working with. But in this case, I'm using the Andes AX45MP, and here I can also make use of CoDense. But what I want to show you is if I start here with no optimizations, so what kind of results we get here on the output, and I will just build it. And as we can see, it's already up to date. And if I scroll down here, we got mainly 65K. I will just make a note of these results. And next step is then, of course, move to higher levels. Let's go for high size. Let's see how much the compiler can do here for you. This should be a straightforward process, just rebuilding all the modules. Great, so now we are done here with the optimizations, and as you can see, it's kind of significant. And we already reduced here from 65K to 53K, but of course we want to do more. And here is where we enable the CoDense extension, and we will get way more out of it. So if I just build again the project pretty quickly here. Great, and we are done once again, and the final result here is 50K. So as you can see, by enabling the optimizations from the compiler plus the CoDense extension, you can definitely reduce the size of your application. So we mainly went down here from 65K to 50K, and that's roughly 27-28% smaller code, and that can definitely benefit you. So additionally, once we have built the project, what we can also do here, we support various probes here, and from IAR systems is actually the iJet driver that I'm using here, together with this FPGA board where I'm running this Andes core. So what I'm going to do, I will just download and connect to this target. So that's pretty straightforward, just downloading the build application to the target. And from here we will reach main, and we can mainly step in, step over the various lines of code, even on assembler level. So you just have to choose what you want to do. This example is pretty simple. It's JPEG decompression, and what you can do here is actually go into the details You can of course use various breakpoints, conditional breakpoints, data breakpoints. You can look into the memory registers, stack information. So all really handy and useful for you. I will just leave the application running here, and we have terminal IO open here that will print some information about this use case. Once it's done here, it will just stop. And this is what I quickly wanted to show you. So as you can see, IAR Embedded Workbench version 3.11, it's available. We support many devices. We support the latest extensions that our partners are supporting. We have a very aggressive compiler on the optimization side, and the debugger gives you full control while doing your debugging. Additionally, one information that might be interesting for you, if you are also familiar with VSCode, I'm just opening here the website. You will see that we have extensions for Visual Studio Code, and IAR Embedded Workbench and IAR build tools for RISC-V are also supported. So you can mainly use the two extensions, IAR build extension and IAR CSPI extension, so you can build and debug your application using VSCode, but the IAR technology in the background. Great. So as you can see, version 3.11 is here, and pretty fancy features have been added. So make sure to download your evaluation version from iar.com/RISC-V, and thank you for your attention.